So let's look at the screw connections in Solid Genius. Make sure the Solid Genius is switched on as a module, and here we have two profiles connected with two plates, and I will show you a bolted connection consisting of screw, washer, holes on both plates, and nut. Alright, let's just select the screw. Every screw inside Solid Genius has its own screw connection menu. Select the parameters. Here visually I can set the connection parameters. I select the washer with material, and on the upper part there will be a simple hole, on the lower part simple hole as well. The holes will be machining holes, and I select the materials for washer and nut. And in the second tab we can set the chamfers. The third tab I can decide how much is the screw looking out of the nut. That's all. So I select the upper part and the lower part. Now I have to just give a point for screw direction, and here we have some work plane and construction geometry functions embedded into the menu. This gives you the chance not to leave the dialog. So here I can just directly draw some construction geometry to set the position of the screw. This work plane will automatically will be deleted when I leave the dialog. Okay, let's set some lines. Now I got the middle points, and simply by selecting the point on the 2D, I select the diameter of the screw. Okay, the length is not important because the length will be measured automatically. So even I set any length, you will see that once I say next, the length will be calculated automatically. Okay, I change the diameter to make it a little bit bigger. Now I said okay, and now you will see that the length of the screw has been automatically adjusted to the the thickness of the plates plus the nut and the washer. So I can immediately go to clipping plane, make a check without screw. As you see, there are two machining holes, both simple holes created on both plates automatically. Alright, so I continue. Next steps is I stay in the dialog and keep selecting points, and with the next option just simply one by one I do all necessary bolted connections. Alright, now as you see we are all set. The holes are here on both plates. Now I want to continue on the other side. I still stay in the dialog and add parallel lines 20 millimeters. Okay, so that's all. Then I again select the middle point, and with the next button, because the parameters are still kept in dialog, I just keep putting further bolts. Okay, this was an example with two plates. What would happen if you would have more than two plates. Okay, so Genius also supports connections with more than two plates. In this case, all you have to do is define the upper plate as the first plate and all the other plates as the second plate. So as you see, they're all shared parts, all the screws and nuts. Here we go. Here's the example with three plates. We have 1, 2, and 3 plates which we want to connect. I select the same part, and the parameters are left over from the last selection. That's why I just simply select the upper part as the first and both parts in a row as the second and as the lower plate. Okay, so I've selected two parts as lower plate. and put the work plane again, make some construction geometry, to find points for the. Okay, here we go. Just now, again, the feedback shows the last length, which was 90, and if I say next, at that moment, Solid Genius calculates necessary length, standard screw length, and as you saw, it took 65. So you don't have to deal with setting the lengths. Okay, I just show off the labels, machining labels. Okay, and then if I would say yes, this work plane with the construction geometry disappears automatically. Alright, and as another example will be just to show you connection with a blind threaded hole. It works the same way. I select just any screw, and as every screw, this one also has the screw connection function inside. I change the parameters. In this case, I would like to have a counter bore hole and no washer. Counter bore hole, okay, and I set a threaded blind hole, and as the screw length, I can decide here, how long the screw length in the last piece of the last part will be. Okay, select the upper part, the lower part, and here again I need, okay, take this one, I project the upper one, and just to know the limits, center, bisector, bisector, both of them. So I've got these 2 points which I need. Alright, select the point, say next. As I say, again, the length is not important, so it will automatically calculate the necessary standard length of the screw, and put the clipping plane to check how it looks like. Okay, this the minimum screw length inside the second part is kept. Okay, so that's all. And then just to remind you that you can also save your parameter combinations and reuse them as you wish. So to do that, I should just okay, here we go. Just start the parameter menu again, and just simply say, give a name and say store. So I go to the save tab, and I have one already. I select the diameter. If I don't select the diameter, I can use these parameters on every diameter, but I can also fix the diameter. Like in this case, I fixed it to M12 and say store. Okay, next time when I enter this particular screw in the predefined, I will see list. I will drop down this. I will see my values. Just in this case, you have to just go click this, select the upper and lower parts, and select the positioning point, and all the parameters you have set are automatically read from the file. Okay, so thank you for watching.